Okay, this is exam 2 for physics 201, fall 10. Which of these statements about projectile motion is true? Alright, the y component of the velocity is 0 at the top of the trajectory. Okay, that one's true. Let's just look at the others though. Acceleration in the y direction is 0. That's not true. It's minus 9.8. X component of the velocity is largest at the beginning. That's not true. It's the same throughout. And the y component of the velocity is constant. That's not true. It changes throughout. So the answer is A. You drop a package from a plane flying at a constant speed in a straight line without air resistance. The package will fall right under the plane. So that's D. Which of these punts has the longest hang time? They all reach the same height, so they all have the same hang time. This figure shows an inclined plane with a block. And the block is accelerating up the inclined plane. The three forces, which of the following is an equation? So let's just draw a vector diagram. This is the coordinate system. This angle is 60 degrees. So if I resolve the force weight vector, I have my normal force. This is my force. This is the x component, Fw cosine of 60. And then this is Fw sine of 60. So let's look at these. Fn minus f is equal to 0. Alright, that doesn't fly because these are 90 degrees, so that doesn't work at all. Fn minus Fw sine 30 is equal to max. Alright, two reasons that's wrong, because this is sine of 30, but it should be sine of 60. And then also we have an ax here, and these are in the y direction, so that doesn't work. Fw sine 60 is equal to Fn. Alright, that is true, and this is only because the acceleration in the y direction is 0. So if we have Fn minus Fw sine of 60 equals may, this goes to 0, so then we can say that this is true as well. So the answer is C. Anti-lock brakes keep the car wheels from locking up when you stop your car. Why does this help slow the car down? We know that static friction is better. That means it's bigger than kinetic friction, so we can get rid of this and this, and we know that mu s is greater than mu k, so that leaves us with option D. The card is on a horizontal frictionless table. Once the card has been pushed and released, what will happen to it? It will continue at a constant velocity. And that's Newton's first law. Block of mass m rests on the floor of an elevator. It's accelerating upward. What is the relationship between the force of gravity and the normal force? Alright, n is greater than mg. If you just look at Newton's laws, this is your elevator, it's accelerating upward. This is the normal force, this is the weight. N minus W is equal to ma. So N is equal to W plus ma. And since A is positive, N is greater than W. That's C. Box is being pulled across a rough floor at a constant speed. What can you say about the work done by friction? Alright, friction does negative work because the displacement and the force are opposite directions. Ball tied to a string is being whirled around in a circle. What can you say about the work being done by tension? The tension force, T, is perpendicular to the displacement, D, so that means it does no work at all. That's C. Car starts from rest, accelerates 30 miles per hour, then later accelerates 60 miles per hour, which requires more energy. Our change in kinetic energy is 1/2 mv squared, and so our change in kinetic energy is 1/2 mvf squared minus 1/2 mvi squared. And the point here is that 60 squared minus 30 squared is greater than 30 squared minus 0 squared. So that means that it requires more energy. If you plot the energy, the kinetic energy versus the speed, it's a parabola, right, because it's v squared. So as v increases, the kinetic energy increases at a greater rate. It's not linear, it's quadratic. Which of these is best approximated as an inelastic collision? Inelastic means that only momentum is conserved, not energy. And collision of two cars, energy is not conserved in that. And collision between a baseball and bat, energy is not conserved in that, because you have a lot of energy lost to heat and sound and all that business. So 11 is 1 and 3. That's option C. Collection of particles has a total kinetic energy of 0. That means that their speed is 0. What can we say about the momentum? Well, if the speed is 0, it means the momentum is 0, so that's C. Uranium nucleus is at rest, it undergoes fusion, and splits into two fragments, one heavy and one light. Which of these statements is true? Alright, let's just look at them. The lighter fragment has more momentum. That's not true. They both have the same momentum. The heavier fragment has more momentum. That's not true. The lighter fragment has a higher speed. It has the same momentum, but a much smaller mass, so that means that it has a higher speed. and D. Alright, a net force of 300 newtons acts on a 200 kilogram boulder and a force of the same magnitude on a much smaller pebble. Complete the statement. The rate of the change of the boulder's momentum. First of all, the rate of the change of the momentum is delta P over delta T, and we know that this is equal to the force. So, if the pebble and the boulder have the same force, they also have the same rate of change in momentum, regardless of their mass. So it's the answer here is A. It's equal. Amy is 100 pounds and Gwen is 50 pounds, and they're standing on slippery ice and push off of each other. So here's Amy. Here's Gwen. Alright, Amy is twice the mass. She slides away at 4 meters per second. And since Gwen is smaller, she slides away at twice that, 8 meters per second. That's B. Alright, consider this figure. The coefficient of kinetic friction between the inclined plane and the box is mu k equals 0.1. If the right hand mass is 4 kilograms, what should m1 be so that it accelerates down slope? So our acceleration is equal to 2 meters per second squared. Down slope, this is a positive value for this one. So let's just write our equations. First draw our vectors. This is going to be FW1, and then the tension in the rope, which I'll call Ft, and those are the only forces acting on that one. And here I have Ft again, which is going to be the same tension that's acting on M1. I also have Fk. It opposes the direction of motion, so it's upslope, and force weight 2, Fw2. Alright, oh, and then the normal force as well, Fn. Now I'm going to draw a vector diagram where I resolve these vectors on M2. So this is Fn, Fw2 cosine of 60. Oh, so this angle right here, rather, this angle is 60 degrees. So this is Fw2 cosine of 60. This is Fw2 sine of 60. And I have Fk and Ft over here. Fk and then Ft here. So I can write a number of equations just from this set of vectors. I can say the sum of the forces in the y direction is equal to m1a. So I say Ft minus Fw1 is equal to m1a. Alright, and remember, I know what m2 is, but I'm trying to find what is m1 equal to. So I can write some other equations. Just looking at the other set of vector diagrams. So I have Fn, looking at the y vectors, Fn, as looking right here, Fn minus Fw2 sine of 60 is equal to may, but the acceleration in the y direction is equal to 0, so that's just equal to 0. And then I also have Fw2 cosine of 60. Fw2 cosine of 60 minus Ft minus Fk is equal to m2a. And in this case, the acceleration is not 0. The acceleration is equal to positive 2. So I'm just going to leave that as it is right now. And so those are the only equations that I have. I can first solve for the normal force. I'm going to do that right here. I'm going to take this equation and solve for the normal force. Fn is equal to Fw2 sine of 60. That's m2, which is 4 kilograms, times 9.8 times sine of 60. And that's equal to 34 newtons. Alright, then I can also solve for Fk. This is the first step. Fk, I know, is equal to mu k times Fn. And since I now know what Fn is, and I know what mu k is, it's 0.1 times 34 newtons. This is equal to 3.4 newtons. So I'm getting some of my unknowns and figuring them out. Now, I can take this equation right here. I'm going to solve for Ft. Ft is equal to Fw2 cosine of 60. Sorry. Fw2 cosine of 60 minus Fk that's all. and that's equal to 4 times 9.8, that's m2 times g, times the cosine of 60, minus 3.4, which I found up here. And so my tension is equal to 16.2 newtons. Alright, so now I have everything that I need. I can come back to this equation, which has my m1 in it, and so I solve it for m1. m1 is equal to ft minus fw1, which is going to be m1 times g, over a. Oh, actually, let's see. I messed up here. I need to. Let's just come back here. I have ft minus m1 times g equals m1 times a. So I have m1 times a plus g is equal to ft. So m1 equals ft over a plus g. So that's ft, which is 16.2 newtons, divided by a plus g, that's 2 plus 9.8. Shoot. It's 2 plus 9.8, and that's equal to 16.2 over 11.8, 1.4 kilograms. 1.4 kilograms. So that's my answer. M1 is equal to 1.4 kilograms. Alright. Force given is applied to a body as it moves in a straight line, and I want to know what work is done by the force. Well, work is equal to F dot D, the force dotted with the displacement. And so my force is 40I plus 20J plus 60K dotted with 32 minus 16. 32 minus 16 in the I direction, plus 10 minus 3 in the j direction, plus minus 12 minus 0 in the k direction. This is just R2 minus R1. So 32 minus 16, 10 minus 3, and then negative 12 minus 0. So if I write this out, I'm just going to multiply now the I, j, and k components together. So let's see, I have 40 times 16 times I dot I, which is equal to 1, plus 20 times 7, plus 60 times negative 12, and that's equal to 60 joules. Okay, a force given by this equation acts in the x direction. Calculate the work done by the force acting on an object as it moves from -2 to 4. So the work is equal to the integral of the force dx. That's the integral of 2x to the 1/2 from -2 to 4 meters. And the integral of this is 2 times x to the 1/2 plus 1, so that's 2x to the 3/2 over 3/2, which is 4/3 x to the 3/2. And then we want to evaluate this from -2 to 4 meters. So this is going to be 4/3 times 4 to the 3/2 minus 4/3 times -2 to the 3/2. Actually, this is going to be a problem. I'm going to change this, and we'll make this from +2. So here we're going to have a +2 from 2 to 4 meters. I'll change this on your test from +2 to 4 meters. So +2 to 4 meters, because you can't take the 3/2 root of +2. So let's see. This is 4/3 times 4 to the 3/2 is 8, minus 2 to the 3 halves, which is 2.8. And this is equal to 6.9 meters. 6.9 meters. Okay, a particle slides along the frictionless track shown in this figure at point A. The particle has a speed of 3 meters per second. Find its speed at point C. I want to know its speed here, and the approximate location of its right-hand turning point. That is, it comes up to this point to a certain height, and I want to know what is this height equal to, where it stops. Now, here we have both kinetic energy and potential energy because it's moving and it's at a particular height. Likewise, here we have kinetic energy and potential energy, but here we only have potential energy because the kinetic energy is equal to 0. So we'll call this we'll call it at point C, and we'll call this at the top. So let's just find, for part A, the speed at C. So we take the total energy here and set it equal to the total energy here. So KE at point A plus PE at point A is equal to the kinetic energy at C plus the potential energy at C. And so this is 1/2 mVA squared plus m times g, and I'm just going to go and put in the height here. It's 3.8 meters. And that equals 1/2 m VC squared, which is what we want to know, plus m times g times 1.3 meters. Alright, so our masses all cancel, which is good because we don't know the mass. And let's see, I know what VA is. It's 3 meters per second squared plus 9.8 times 3.8. That equals 1/2 VC squared plus 9.8 times 1.3. Well, let's see, that's 4.5. I get 7.6 meters per second for VC. 7.6 meters per second solving this. So that's the answer for part A. And then for part B, we just take this, kinetic energy at A plus potential energy at A is equal to the potential energy at the top, at the furthest right hand point. And we do the same thing. 1/2 m, I'm going to go and put in the speed here, 3 squared plus m times 9.8 times 3.8 is equal to m times 9.8 times h. And all of our m's cancel. And solving for h, I get h to be 4.3 meters. So h is 4.3. And that's the answer. Alright, a 1,000 kilogram compact car is moving with velocity v1. It skids on frictionless icy patch and collides with a 500 kilogram hay wagon moving with velocity v2. If the two stay together, what is their velocity? So this is straightforward conservation momentum. Pi is equal to Pf. So my Pi is the mass of the car times v1 plus the mass of the wagon times v2. And that's equal to, these are all vector quantities, the mass of the car plus the mass of the wagon, because they stick together, times Vf, I'll call it. And we want to know, what is this equal to? What is Vf? So let's put in some numbers. We have 1,000 times v1, which is 20i plus 40j, plus 500 times v2, which is 10i minus 5j. And that's equal to 1,500 times Vf. So I would want to just keep all my i's and j's separate. So I have 20,000 I minus 40,000, plus 40,000 j plus 5,000 I minus 2500 J. If I divide all these by 1500, that'll give me VF, and I just retain the IJ notation, and I just ask for it in vector notation. So let's see, 20,000 I plus 5,000, that's 25,000 over 1500. And then 40,000 minus 2,500 is 37,500 over 1,500. And that's in J. And let's see, 25,000. That's 16.7 I plus, that's 25 J. This is in meters per second. That's the answer in vector notation.